Okay, we're good to go. Welcome. Welcome to this session where we will discuss Jax-Rs and CDI. Just for the intro. Yeah. My name is David Delabassee. I work at Oracle in the Java and container native organization where we are doing technologies such as Java-E, Java-C, open source projects such as GlassFish, Jersey, OpenJDK, but also other cloud-based stuff. So, as I said, I work at Oracle. Before that, I spent 10 years at Sun working on working on Java, server side, but also client side. And even prior to that, I was working in a telco in Belgium, because I live in Belgium, where I was also working in the early days of Java. So basically, I've been spending quite a few years with Java. In fact, my first Java one, the first Java one that I attended was in 1998, so almost 20 years ago.
And my name is Jose. I live in the Paris area. It's really hot, in fact, with the sun. I should remove that. It's not that funny, in fact. You can follow me on Twitter. It's a technical Twitter account only. And I also have content, open source projects on my GitHub account. The slides of the presentation will be made available on SlideShare too, just after that. You can also follow me on YouTube. And I think the next slide is for you. Yeah. So, as I told you, I work at Oracle, and a few months ago I was in Sweden at JFocus where I was giving a talk on Java 8, and someone in the audience tweeted that it's not a real conference unless you read Oracle's safe harbor statement at least once. So, enjoy. Now, joke aside, you can try to understand what this is saying, but basically it says that you shouldn't make any purchase decision based on any forward-looking statement that I will make. Today we're going to discuss Jax-Rs, Jax-Rs 2.1, and CDI 2, and also the CompletionStage API of Java EC8. So clearly there's no forward-looking statement. So you're safe on that front. Having said that, despite my French accent, I'm not French. I'm from Belgium. And despite my Belgian accent, I'm not from Belgium. I'm from France. Sorry for him. French. So the title. Well, let first give you an explanation, set the context of what we're going to discuss today. So in the title, we are using a reactive term. So basically, Jax-Rs and CDI can help you to cross the reactive bridge. Now, if you look at the Reactive Manifesto, so the Reactive Manifesto talks about elasticity, resiliency, mesh-driven, and also the idea here is that we will talk about being reactive in the sense that reactive in this context means having the ability to react on event, right? And obviously, at the end of the day, if you are able to react on event in an efficient manner, basically in an asynchronous fashion, your application at the end of the day will be able to cope with more load, will be able to scale easier, and so on. So this is really what we mean by reactive, having the ability to program applications that react in a very easy fashion to event. For that, we will use two API, Jax-Rs and CDI, which have been defined in Java 8. So we will really use the latest version of those API. Java 8 has been finalized, so those API are finalized and stable. But having said that, even though those API are coming from the Java platform, you can also use them just on top of Java EC. And in fact, if you look at Jax-Rs, Jax-Rs is obviously heavily used in the Java EC space, but Jax-Rs is also used standalone on pure Java EC context. So what we're going to discuss today apply obviously to Java EE, but it also applies to Java EC. So you take Jax-Rs and or CDI on top of Java EC8 or Java EC9, and the pattern that we are going to discuss today will work exactly the same way. So it's not a pure Java EE talk. So let's talk about Jax-Rs. So in Java 8, we have Jax-Rs 2.1. If you look at Jax-Rs, in Java 7, the major
addition of Jax-Rs in Java 8 was this new client-side API. So basically, since Jax-Rs 2, Java 7, we have an API that we can use to easily consume a REST endpoint. Now, if you look at Jax-Rs 2.1, there are a lot of stuff that are being done. But let's focus just on the client-side API of Jax-Rs. And in fact, this example is a Jax-Rs 2 example. So how it works if you want to consume a REST endpoint? Well, you first need to have an instance of a client-side container. So this is really a Jax-Rs client-side container. You get that client container through this method invocation, so client builder new client, and you will have a client container that you can use to invoke remote REST endpoint. Then, once you have the client container, you will, based on that container, construct a web target. A web target is, at the end of the day, just the location of your remote endpoint, so the remote endpoint that you want to access. So this is my target. I have the ability to configure and construct my target. Once you have the target set, you will have to construct the request. And obviously, at some point in time, you will invoke the request to get some result from the remote endpoint. Obviously, given that we have this client-side container, you need to make sure that you close that client container once you are done. Nothing really new here. So what we have in Jax-Rs 2, we have this Fluent API that you can use to easily construct and invoke REST request. So it starts from the client. From the client, you set the web target. From the web target, you construct the request, and then you invoke the request. The key here is that if you look at the bottom of the example, we have this get method. So this is a HTTP get request, but this is really a blocking call. So that means that my method will not return until my remote endpoint has sent me the result. So this is the default behavior. This is a blocking synchronous behavior. Now, if you look at Jax-Rs 2, so that's Java 7, we have also added support for an asynchronous behavior. That's what we have at the bottom of the slide. So we have this async method, which is basically used to tell to the Jax-Rs client container that this is an async invocation. And if you look at the return time of that, the return type of that invocation, what we get in return is a future of string in this case. So basically, you have a future object that you will be able to use at some point in time to get the result that will be sent by the remote endpoint. Get the result or see what the error was if something went wrong. So the thing is that this is asynchronous, so when I do my get, my method will return directly. But obviously, at some point in time, we need to access the future object. And if you do that, a get on a future, you know that it's a blocking call. So we haven't really solved the blocking issue that we had with the pure Jax-Rs sync API, right? So this is really blocking. Now, the result needs to come from a remote endpoint through the network. So you also need to make sure that you set some timeout. You will set some timeout directly on the get, but you'd better also set a timeout at the Jax-Rs level to make sure that at some point, well, worst case scenario, your code will block for, let's say, 5 seconds, but not more. But this is still blocking, so this is not what we want to have. No, let's skip that. Let's keep that too. So where I want to go is to this. We have an asynchronous behavior in Jax-Rs 2, but it's blocking at the end of the day. The good news is that in Jax-Rs 2, we also have an asynchronous invocation callback facility that allows us to work around that blocking issue. So we have an invocation callback with 2 methods. The first method is completed. So it's that callback, that completed method will be invoked whenever we have the result from the remote endpoint. And then we have the fail method that will be invoked if something goes wrong. So it works like this. So it's a pure Jax-Rs client-side request. It's an async request, obviously. It's a GET request. And then we have to pass it an implementation of our invocation callback with the 2 callback that we have. So the completed, that one will deal with the result that will be sent by the remote endpoint, and the fail if something goes wrong. So it's fairly easy to see how it works. Now, if we put that into perspective, so we have a basic microservices-like scenario where we have a travel agency services that will consume 4 backend services, and the idea is the following. So we have a user that comes in, and we would like to suggest to that users, based on his travel history, some destination he might want to visit. For that, the travel agency services will use the Jax-Rs client API to consume the 4 backend services. So the first services will be the customer services. So we want to have the history of that customers. Once we have that, we will reach to the destination services. So we want to have a few destinations to suggest to that user based on its travel history. But before we send those destinations, we also want to reach to the weather services and the quoting services, because we want to add some pricing and some weather information to the destination that we will send back to the user. So that travel agency services will have to implement, using the Jax-Rs client API, some kind of orchestration between the 4 backend services. Now, one thing is sure is that we don't want to do that in a pure synchronous fashion. Why? Well, it's easy. If we just put some weight on the request, we'll see that in this example, we want to suggest 10 destinations. So we first hit the customer services, then we hit the recommendation services, and then we have to hit 10 times the destination services. So for all the destination, we have to hit the quoting services, and also 10 times the forecast services, because we want to have those information. So obviously, the total time to get all the results would be just too long. So we want to go in an async fashion for that. Why? Well, it's easy. I mean, if you look at the graph, we have dependency between services. So for example, we first need to have the travel history. Then based on that, we will hit the destination services. But then we can invoke in parallel the quoting services for all the destinations that we have, and we can invoke in parallel the weather services, because there is no dependency between those services. And at the end of the day, if we can do that in an async fashion, the total time should be way less. So if we try to implement that using the async API of Jax-Rs 2, but before we do so, we have to simplify a little bit, and let's pretend that we just have 2 services instead of 4. So using the Jax-Rs 2 API, it would be something like this. So we first do a request to the destination services, so to get some recommendation. It's an async request. So that means that we have to pass it an invocation callback. My callback needs to have, obviously, my invocation callback needs to have 2 callbacks. Completed will deal with the result. So once we have all the destination, we basically go over all the destination, and we do another request for all those destinations. We do that request in an async fashion. So that means that we have to use again an invocation callback with a completed callback. So basically, when we have the weather forecast for that given destination, we put that in a synchronized map, and so on and so on. And the thing is that obviously we also have to deal with any error that might occur. So we need to make sure that we implement the fail callback too, at the 2 level, because we have 2 type of invocation callback, and so on and so on. I guess you see where I'm going to. This is what we call the callback hell, and clearly writing that code is very difficult. So at the end of the day, you will have code that is difficult to write, debug, and maintain. So clearly, we don't necessarily want to go that route. The good news is that in Jax-Rs 2.1, so in Java E8 timeframe, we have a new invoker, and that is a reactive invoker. If you look at the bottom of the slide, we have this Rx method. So this is basically how you can invoke the Jax-Rs client reactive invoker. And you see that this is a standard Jax-Rs client-side request. The only thing which is different is the invoker, Rx, instead of async. So this is an async request, but in a reactive fashion. And you see that the return type is not anymore a future type of the response, but it's a completion stage of the response that we do expect. Now up to you.
Thank you. So, in fact, the following of the processing of this data turns out to be finding the right completion stage patterns that we want to use, just to complete and to get the result in an asynchronous way. Just a quick poll before I continue. Who was at Venkat's talk about completable futures and streams and things like that? Okay, so not that many people. All right. So we are going to see that first. What is a completion stage? From a pure technical point of view, a completion stage is an interface from Java 8. So starting Java 8, you can use that. It's an extension of the future object. So everything you can do with the future object, you can do it with a completion stage. From a design point of view and design pattern point of view, in fact, a completion stage can be seen as a model of a task. It's triggered by a task, so it contains a task, and that completion stage will allow us to communicate with that task both in a synchronous fashion as with the get method from the future object, and in an asynchronous way with the new methods introduced on this interface. This task may be set as part of a chain. Remember that to interact with the future object, you need to have a reference to it. And basically, what you can get is, are you done? Give me the result, or cancel this kind of thing. So you can give orders to it. And the bridge must be on the thread that launched the task and the thread that is executing that task and built that future object. So this future object is in fact a bridge between the thread that created the task and launched it and the thread that is going to execute that task. A completion stage is different. A completion stage is really a fire and forget object. You create it, you configure it, and then you forget it, and it will kind of work, hopefully, the way you want it to work. We can see two basic operations on the completion stage. First, trigger the beginning of a task on the completion of another task. We have many methods for that. The idea is to apply a function to the result and to trigger that function once the task here, CS1, is done. And we have a second function to that, which is the then compose method that takes a function that itself returns the completion stage. On the example we are going to see, the situation is the following. We made a request on the weather service, for instance, to get the weather forecast. This weather service will return a response sometime in the future. We don't really know when we will have this response. But on the completion of this weather service, when we have this forecast, which will probably be a JSON object, what we want to do is trigger the unmarshalling of this JSON object. So this task is a purely synchronous task. It will not return the completion stage itself. So we will trigger this unmarshalling stuff with this then apply method, just because the unmarshalling will not take much time. It will be done synchronously. But suppose that the triggering of the weather forecast triggers another request on the destination service, for instance, because the forecast is bad and you don't want to send your customer there, because what this person wants is to have the sun on the beach, for instance, something like that. Then it will be another asynchronous task, so you will need the then compose method to launch the second task and get another completion stage. So this then apply can be seen as a mapping operation, and the then compose method can be seen as a flat mapping operation, if you want to put that in a stream API perspective. This is the first kind of pattern. A task triggers another task. But we can also have several tasks, here too, that are both triggering a third task. We are going to see an example of that. And this kind of pattern is triggered with the then combine family of methods. Once again, there are many methods, in fact, in this completion stage API to do this kind of thing. All right, so with those two basic operations, we can then create any kind of pipelines we want. We have a first task that is asynchronous. Suppose the get destination, the destination request service, the destination service, that we are requesting. Then when we get the destination, maybe we want to trigger a request on the weather forecast. This is the second task. But we probably also need to send some kind of information in some kind of logging service or email service or whatever. So we can also trigger a second task that will do some side effect and things like that. In the first branch of the pipeline, once we have the forecast, maybe we want to do something else with it. So there is another task that is triggered. And this third task will in fact have to wait for another task that has nothing to do with it. But on the completion of those two tasks, 31 on A, we are going to trigger the last task of our process. So this is the kind of pipeline that we can build using this completion stage API. Now, how can we move that to our example travel service agency? We have the client target forecast that is going to to ask for the forecast of the destination once we get the destination. We call this RX method from the Jax-Rs API that will, in fact, create an asynchronous task and return this completion stage object. And since this is a REST service query, it will return, of course, a JSON object. Now, this JSON object, we need to unmarshal it. The unmarshal operation is not going to be asynchronous because it's a quick operation. We can just do it like that. So we just create a function to do this unmarshalling, and we will apply this function once we have the destination. Yes, this is just basic JSON code. So once we and to trigger the completion, the second task on the completion of the first one, we need this then apply method in our code. What is this then apply method will take as a parameter? Well, it will take a destination as a parameter. So this is going to be a function that takes a destination, query the forecast service with this destination. Hey, this is picture time, David. Thank you. Can we have another one without the, the hats? Thank you very much. Thank you very much. Because Stefan will think that we're making fun of him. So we shouldn't be doing that. Okay, where was I? Yes, the destination. So we have this destination. Once we have this destination, with this destination, we trigger the weather forecast. And once we have the answer from the weather forecast, we need to unmarshal the JSON object we got. So this is basically the two steps of our stuff. This is obviously a function that takes a destination, and since this then accept method takes a consumer that does not return anything, it will return instead a completion stage of void that is just here to tell us that yes, this task has been has completed properly. Now, the choice that has been made here is that we have a destination object. This is our model, and in that destination we have some kind of forecast property. And the system is going to set the value inside this destination object. So we could have made other choices, but this is the design choice that we've been made. So what we want is, in fact, to populate some fields of the destination object with information that are coming from REST services requests. Great. We can do that with any kind of other property. Here we have a quotation also. So we have two services, forecast and quotation services, that are going to set two different properties of our destination object. Right. So this is the basic block of our system. Now, when we want, what we want really is that we have several properties to set in the destination object. And what we want is another completion stage that will tell us, hey, I'm done populating all the different properties of that destination object. So in fact, we are going to wrap all the requests that are made in parallel, of course, because everything is asynchronous, all the requests that are made on the different services that are going to update this destination object, and wrapping all those completion stage in a single completion stage that will be done, that will complete once all the sub-completion stage are complete. We are on the 2 then 1 branch of the graph we just draw a few minutes ago. Right. So this is really our final function, takes a destination and returns a completable future void that tells us the destination is completely updated with all the information we need to have. But now, what our services returned us was a list of destinations in a single request and not a single destination. So we need to further convert that in, we have a list of destinations. For each destination, we are going to make asynchronous requests. So what we would like to have is a list of completable future that we will further convert in a single completable future to know that, in fact, all our destinations have been properly updated with the result of those requests. So this third function takes that list of destination. That list is going to be, we could have done that with a for loop, all right, but this is Java 8, so we have a stream API to do that. So we are going to stream this list of destination, map that stream with this populate destination that is going to populate a single destination with all the properties requested from other services. And this is a mapping that, in fact, takes a destination and returns a completable future, a void in that case, because it is just the previous method. This mapping will return immediately because we are just creating completable futures that are going to be created immediately. They will not complete immediately, but they will be created immediately, synchronously. And we are going to put all those completable futures in an array for the next processing step. So in fact, we have 3 levels of completable futures. First, and we just saw the first 2. The first level is to update all the destinations. It itself is triggered by the completion stages that are triggered by all the individual properties of each destination object. And when we gather that in another level, because what we have is a list of destinations. Right. And the next step is, in fact, to compose the destination request that we just made on the destination service with this populate destination. Let me quickly go back to the previous slide. This populate destinations is the function that takes the list of destination and returns me a completion state that will complete once all those destinations have been updated. So I'm taking this big asynchronous completion stage task, and I'm composing it with the destination, with a request on the destination service. And at the end of the day, the pattern is really simple because it's just a composition of 2 functions. Great. And then if I want, the problem is that this completion stage all off returns a completion stage of void. And what I would like to have is a completion stage of list of destination. So here I'm just using a trick. I am further composing that with just this simple function that will return, in fact, the list of destination. So this is a pattern that, in fact, takes a list of objects asynchronously from a request on a REST server, but it could be, of course, anything else. Each object will be analyzed and updated asynchronously with other requests on other services. Everything will be gathered for each object. Then all the objects are gathered in a single list. And at the end of the day, we have a single completable future that will complete when all the operations, all the sub-operations have completed, which is what we wanted to do, in fact. All right. So if we put all this in a single pattern, these populate destinations rest for Jax-Rs. How could I say Jax-Rs method? It's a pure Jax-Rs method. We get this asynchronous. We have in fact 2 patterns. Is it your?
So yeah, maybe I should explain. So so if you know Jax-Rs, you know what that at suspend annotation does. So basically, it's a way to tell Jax-Rs. So we are on the server side. It's a way to tell Jax-Rs that we have a request coming in and we want to pause the request processing, meaning that we will do some heavy lifting computation in a different thread. And at some point in time, we will resume the request processing from that external thread. So it's basically a way to deal with long operation in Jax-Rs. So it's a Jax-Rs resource method. We tell Jax-Rs that we want to pause the request processing because we have to invoke many backend services. Like here we have this completion stage that will go to the destination services and so on and so on. And then what we are doing here, we are performing our execution flow. So this is basically our execution pipeline where we deal with all the results. And then we need to tell to Jax-Rs that, okay, we have all the results, so now we want you to send the result back to the client, right? So for that, we are using the async response object that we have injected in as a method parameter. And on that object, we have the resume method, which is basically when we say Jax-Rs, okay, now you can resume the request processing. And obviously, we have to pass the result that we get through our completion stage pipeline execution, and that result will be sent to the client. So that's why we have the get at the end. So basically, we want to have all the results, and we want those results to be sent to the client. Now, something which is important, we are pausing the request processing on the server side, but clearly the I/O thread will be blocking on the server side and on the client side. So the client, even though the request processing is done in an async fashion on the server side, the client will have to wait, obviously, that it gets the result from the server side. So this was the old way of doing things using JAX-RS 2. And now in JAX-RS 2.1, we still have the ability to inject the async response object to pause the request processing, but we can also do it in a different way. So if you look at this method, this is again a JAX-RS resource method, but this time this method is returning a completion stage. So this is basically a way to tell to my JAX-RS container that we want to pause the request processing. And all it takes then is for that method to return the completion stage object with all the results. And once that completion stage will be executed, JAX-RS will use that to continue the request processing. So basically send the result back to the client. So here we are. Before we have explained you how you can use basically the completion stage and JAX-RS client-side API. And here we are going a step further. We are using that on the server side, and we are also using the completion stage facility of JAX-RS 2.1 to also handle long-running operation on the server side.
Yeah. The biggest difference between this pattern and the previous one is that this pattern will execute very fast. Why? Because all we are creating are completion stage objects that are created immediately. The previous pattern, there was this get call that was blocking, so the method would not have returned until the result would have been is available, which is not the case here. This some more technical completion stage code. It's just the creation of the function that I showed you on the previous slide. So everything is created just immediately in this pattern. Now the question is, what happens if some kind of error is coming in a pipeline? Let us take the previous schema I showed you just a few minutes ago. Suppose that CS21, which is a request on some kind of REST server, cannot complete because the REST server is down or anything. All right. So this completion stage is in error. The API tells us that, in fact, all the downstreams completion stage of the graph we've been building will also complete exceptionally if we do not do anything. So it will, in fact, crash all the pipeline that we created. Now, the nice thing is that this completion stage API also provides a method to handle errors, get the exception and do something with it, and either we throw it to say, okay, yes, all the pipeline is in error, so we cannot compute any kind of result. But you see that in the case we are dealing with, this destination example, maybe if we do not have the weather forecast, it's not too bad. We can live with it. It will be a missing information, but it doesn't have to break all the process. So we can also do that with completion stage. In fact, we have a first method called exceptionally that returns a new completion stage. So it's really a call that can be integrated in a chain of asynchronous processing using this API. It will complete when the completion stage it is called on completes itself. So there is no lag or whatever in this call. Either with the same result, which is the normal completion. So if this did not throw any error, any exception, this exceptionally completion stage will just be transparent. Nothing will be made in it. Or it will trigger, or if there is an exception, the exceptionally method will be called, getting that exception, and then we can do something with this exception. We can log it. We can decide that this exception is not too bad, and then just swallow it and continue the processing normally. Or we can withdraw it just because we think that all the process should stop. This is the first and I would say most basic method that we can call to handle exception. There is, in fact, other exception. There is the handle exception that will take both the result and the exception as a B function, and that can do the same kind of thing. taking some kind of decision on what to do with that exception. The difference is that this time this B function will be always called with the result and with null if there is no exception. It was not the case in the previous example. And we also have a when complete method that also takes, this time it's a B consumer and there are asynchronous versions of it. So suppose that we are querying a given weather forecast server and that this server is not there. With this when complete method, if there is an exception, we can decide to trigger, to request for another weather forecast, for instance, and get a result that would be maybe different, but that will still be valuable to the customer. Right. So those are the patterns of the exception handling. First, with we have this quotation service that is requested with the then apply and marshal operation. Suppose that something goes wrong either in the request itself or in the unmarshalling operation. Then we can call this exceptionally method and just, for instance, decide to swallow the exception. It's not so bad if the quotation service did not respond. Maybe it is, but in this example, it's not so bad. And then we continue, then accept destination.setQuotation. So in fact, here, we are just getting the exception, decide that the quotation is not there, so we return null, because we do not have any quotation, and we'll just set the null value in the quotation field of the destination object. So it's a way of handling the exception, saying, okay, not too bad, the destination object will not have its quotation, but we can live with it. This is another way of doing it. We can also have called this handle method that will take the quotation and the throwable, and then if the throwable is null, set the destination. If it's not null, do something else. Right. Try to do something smart with this exception. So inside this CompletionStage API, we have everything we need to handle exception and either rethrow them or deal with them in a normal way, and log them and do them, handle them in a way it will not break the whole process of the pipeline we are doing.
Okay, so we have talked about this new reactive invoker that is part of Jax-Rs 2.1. For our example, we have just used the get method, but obviously it's supported by all the method that the Jax-Rs client-side container supports. So it's basically all the HTTP method except the patch method. So you can use the reactive invoker on all those HTTP verbs using the Jax-Rs client-side API. Now, we have discussed a lot about the CompletionStage API of Java EC8, but on the Jax-Rs side, we also acknowledge that there are other reactive API on the market. So if you look at the specification, the Jax-Rs 2.1 specification has been written in a way so that it's open. So the specification says that if you want to be compliant with Jax-Rs 2.1, you need to support the CompletionStage API, so this new Rx invoker. But the specification is also open to other solutions. So a Jax-Rs 2.1 implementer might decide to support other API than just the CompletionStage API of Java EC8. And in fact, that's what we do in Jersey. So in Jersey, we obviously support the CompletionStage API, but we also support the listenable feature from Guava, and we also support RxJava and RxJava too. And that means that basically you will be able to use those reactive API, and obviously the pattern that we have discussed will slightly change, but at the end of the day, you will see that it's very similar. Now, let's move on quickly to CDI, because CDI, well, first play an important role in the Java platform, but this is not a Java talk. So if you look at CDI 2, which is part of Java E8, but again, you can use CDI outside of Java EE, and in fact, it's one of the big focus of CDI 2, being able to use CDI outside of Java EE. There's a new addition which is quite interesting. So you know that in CDI we have since the beginning an event mechanism. The thing is that that event mechanism is synchronous, so it's blocking. So it's basically a producer-consumer pattern implementation. So you produce an event, and then you will, somewhere else in your application, consume that event. The thing is that you will consume the event in the same thread as the producing thread. In Jax-Rs 2, we have support for asynchronous event. It works exactly the same way, so you inject an event, and then you will invoked a different method. So if it's synchronous, you will invoke the fire method. If it's an async event, you will invoke the fire async method that has been introduced in CDI too. So basically, you are firing an event in async fashion, and then obviously you will have at least one observer that will react on that event. It has to be an async observer. So to tell that it's an async observer, you just need a method, and you use this new @observe async annotation to basically link the two. So we are producing the event in an async fashion, and we are consuming the event in an async fashion. And if you look at when we fire the event, you see that the return type that we get is a completion stage of that given payload. So basically, we have a completion stage object that we can use and combine with the CompletionStage API. So basically, we can combine that with, for example, the Jax-Rs pipeline execution that we have just shown in the previous example. Something also is that if we are running in an environment, we might have to specify the executor services that we're using. Typically, if you're running in a Java container, you will have to specify an executor services. And in that case, that would be a managed executor services. And obviously, you have the ability to specify that on the CDI front, but also on the Jax-Rs front. You can specify the executor services to use. So, wrap up. So today we've discussed two API that are coming from the Java platform, Java 8, that's Jax-Rs 2.1 and CDI 2. But basically we have used them outside of a pure Java typical scenario. Having said that, all those patterns also apply to Java EE. The thing that we wanted to highlight is basically how you can use those new capabilities with the Java EC8 CompletionStage API to evolve your code to be more reactive. So again, reactive in the sense that your code is able to react on events that are produced in an efficient manner. So that means that most of the time we have to do that in an async fashion. Now, these efforts, so Jax-Rs 2.1, CDI 2 are obviously part of Java EE8, so they are part of a larger effort. And very quickly, we've done a lot of other stuff in Java 8, like adding support for HTTP2, adding a new JSON binding API, adding a new security API, and so on and so on. Now, this is clearly not a Java EE8 talk, so I will encourage you to check Java 8, but also to look at those API, Jax-Rs 2.1 and CDI, and give them a different point of view, especially when using the completion stage of Java EC8. So with that, we have a few minutes for questions. So is there any questions or remarks? Yes?
What's the relation between the completion stage and the computable future API?
The completion stage.
So repeat the question.
I'll repeat the question, yes. So the question is, what's the relation between completion stage and completable future? From a technical point of view, completion stage is an interface that extends the future interface from Java util concurrent in Java 5. Completion stage has been introduced in Java 8, and completable future is the provided implementation of that interface. Now, there is something that is kind of unusual, is that in the interface, you have a toCompletable future method that is present, and that returns the completable future object. So in fact, there is a cyclic dependency between the interface and the class. And by the way, I use that in the slides just to match the signature of, maybe you noticed it, just to match the signature of the method. That is, one of the method I was using was taking a completable future, and what the object I was using was a completion stage. So you have this method on this. So yes, this is the relationship between both elements of the JDK. Any other questions? Yes?
When you develop your server-side Jax-Rs with the new completion stage, what happens when you call it with a client, a basic client that doesn't understand basic completion stage?
Okay, so the question is, when you are using Jax-Rs and the CompletionStage API on the server side, what happens if you are calling it with a client that doesn't understand, that is not completion stage or where? Nothing. I mean, it's just Jax-RS call. So it's basically, when I was discussing that we have the ability to pause a long-running operation, request processing on the server side, the client will do a request. We will pause the request processing on the server side, but the client will keep waiting that the server send back the request. So it has no impact on the client side. The thing is that, for example, if you look at the travel agency services, when we are using the CompletionStage API to compose our execution pipeline in an async fashion, we are just reducing the time it takes to basically send the result back to the client. So we are improving the client, but the client doesn't have... I mean, it's pure over the network. We are just doing REST call, nothing else.
Yeah. In fact, when you interact with this service, you don't have to be some Java code. It can be PHP, JavaScript, whatever. Because everything that Jax-RS, well, everything that is seen by the API is just a conversion of an HTTP call, pure HTTP. So it's not necessarily Java on the client side. Here, on the example, it was Java because, well...
Yeah, and also something which is a little bit sometimes confusing is that we have talked about the Jax-RS client-side API, but if you look at our example, we have used the client-side API on the server side. So...
Yeah. Yes, to
yeah.
have this...
Yes.
Is it dangerous to access, for example, fields from the bean when you are in the completion method? Because the bean may have a role of the thread that started the thing is already gone, and the bean may be in some strange stage.
Are you talking about race conditions and things like that? Is this what you're thinking about?
Also,
okay. So the question is, we have a bean that may be created in the main thread, and then we transfer that bean in an asynchronous way to other threads from the pool of thread, from the executor service that is going to handle all the asynchronous stuff, other threads. By the way, all the methods we saw could also, I've said, all right, we're going to launch those operations in other threads from inside the completion, the executor, that executor service. All the happens before links and things like that are set up in the Computable future API so that it's thread safe and so that you won't have any race conditions in this kind of thing. Now we're thinking of other things. If you're getting your object, for instance, from the database, from the transaction thread, and this transaction thread dies because it's the HTTP thread, which is the main thread, and you've returned, you've left the Jax-RS method, and you're just in an asynchronous way. I haven't watched precisely this part of the specification, but since it is done all over the place, I would guess that the Jax-RS guys took care of that, not to let those threads die, and those objects linked to those threads be in some kind of inconsistent or corrupted state for us to yes. But it's a good question. From the pure race condition perspective, everything is in the CompletionStage API, so it's okay.
Yeah.
Do you have further answer, maybe?
Well, just one thing. So if you look at the Jax-RS specification, so Jax-RS basically define how it works on top of Java EC, but also it's also define how it works on top of Java E. So I haven't checked that particular detail too, but I would assume that this is being addressed on the Java E side specification of Jax-RS.
Yeah.
Yes. So the question is there a plan for supporting the streams? I mean, the reactive streams?
No. The
flow.
The flow API.
Yeah.
I mean.
Yeah, which is an implement. Yeah. Not at this stage. Having said that, if you look at the early days of Jax-RS 2.1, there has been some discussions regarding the flow API. The thing is that Java EE8 and hence Jax-RS 2.1 has to work on top of SE8. So that's something that will likely come. And given that we are moving the Java development to EE4J, that's something that will likely come on the EE4J side. Yeah. Yes?
In this example, you are operating on a list of destinations,
Mm-hmm.
and during a stage, you had to have the entire list of destinations to operate on these destinations and to get the result for the weather and let's say you rely on different implementation or different producers of destination, like travel agencies or something like that, and they do not respond in a timely fashion or on the same rate. You have one travel agency which is very fast, you have your first batch of destination, and you have another one, you have your second batch of destination, which is very slow. So you have a first batch which is ready to operate, to get the river and the rates and the everything like that. And the second, you are still waiting.
I think I get your question. So the idea in the example I will repeat for the recording. So the example we get, we have a single destination service that returns a list of destination, and when the downstream operations on the completion stages chain are triggered, this list of destination, of course, is full with all the destination objects. So the question is, suppose we have several destination services responding at their own pace, and we want to deal with that. Well, I think that what could be done is that you have two approaches for that. Either you think that you need to have all the list of destinations to trigger the rest of the processing, then you need to create a completable future that will wrap all those different services and that will complete when the slowest service has complete. Okay? Or the other approach is to say, all right, each service will respond at its own pace. So I will take every service individually, and then trigger the rest of my chain for the quotation, the weather service, etc., for this subset of destination, and then trigger another completion stage for the overall process of all those chains. And if a service is responding too slowly, for instance, since completion stage is an extension of the future object, you have this get with a timeout on it. So if you say, all right, I want the answer in 300 milliseconds, and at that time you don't have it, then you can throw an exception with a timeout, call exceptionally with it, and do something with this timeout, maybe removing the faulty destinations due to the service that was too slow to respond. This is a really powerful API, very rich, and you can absolutely you can deal with the problem you stated with it with this approach. Yes, I think we are our time's up.
Okay. So we would like to thank you for your time.
Yeah, thank you very much for your attention.